fields. Same thing as indefinite integration, same thing as anti-differentiation, same thing as solving differential equations. Now, what have we been doing? Oh, God. Okay, we've been working with differential equations, okay? In the beginning, we started out with something like this, where we had f prime, y prime, dy dx equals something. They were explicit differential equations, okay? Then Thursday, we worked with separable differential equations, where we had to kind of do some work, integrate both sides, and then do a little bit of more work to rearrange things and make it look pretty, okay? Not all the time can we actually solve a differential equation algebraically, analytically, okay? When you get into calculus 2, and then once you take calculus 3, those of you who are math majors will take differential equations, okay? There's going to be a few more techniques that we can use, but there are some differential equations that you just cannot solve. So instead, we represent them graphically, and that's what we're going to do today, all right? So a slope field is a graphical representation hold on, I don't want that word, is a graphical, well, we can write representation. Of general solutions to a differential equation. Okay, so it's a graphical representation of general solutions to a differential equation. No, you will not need to. Now, some of the examples that we look at, we will be able to actually solve, but that's not always, but we'll also look at some that we can't solve, okay? So first, let's look at dy dx equals x squared. I know that we can solve this out, and that's the point of why I chose it as our first example. But what does it mean? If dy dx equals x squared, what does that mean? How would you describe that to somebody? Okay, and what does the derivative represent? Okay, so at any point, the slope is x squared. So do you see that graph you have right underneath? Mm-hmm. We are going to plot all of these slopes. Okay. Okay. So at the coordinate 0, 0, dy dx would equal what? 0 squared, right? So at 0, 0, we're going to plot just a little bitty tangent line with slope 0. Okay? Just a little dash. Okay? What about at the coordinate 1, 0? dy dx would be what? X squared, which is 1. So if you imagine slope of 1, okay, you're going to draw that tangent line, but only a little piece of it.
Oh, and that's the thing that we saw in the book by
What about the coordinate 2, 0? dy dx is x squared. 4. So that's going to be pretty steep, right? And we're going to do that for all across the board. Okay?
Go back up.
What about Y's?
Forget it about
Okay.
it.
Now, since this differential equation doesn't have a y in it, the y coordinate doesn't really matter, does it? But if this was like x squared over y, then we'd be taking the x coordinate squared over the y coordinate. Okay? You're going to plug your coordinate into the differential equation to figure out your slope. Okay? So, Nathan, what is the slope at 0, 2?
0.
Aaron, what is the slope at 0, 1? Okay. Josh, can I get that a little bit?
Sure.
Zach, could I ask you again? What is the slope at 0, negative 1? Jalen, what's the slope at 0, negative 2? Okay. Carly, what is the slope at 1, 1?
1.
If we plug it into x squared, if we plug 1, 1 into x squared, what would we get? We would get 1. Are you okay?
Going to throw.
Zach, 1, 2.
1.
Brady, 1, negative 1.
Negative 1. 1.
Which one?
I'm thinking about it.
Whoa, that's like 3 1s in a row.
You say negative
1, negative 1.
Oh,
Come on, Brady, it's still 1. Or maybe a triple.
Yes, it's still 1.
What, Brady?
Allie, 1, negative 2. Okay. Let's keep going. John, 2, 1.
4.
We have to do it on every single point on this graph.
Yep. Okay, Nathan, I already asked you. Carter, 2, 2.
I think it's going to be 4.
You said 2 2.
Aha.
Tristan, 2, negative 1.
I'm going to say 4. Is that the same thing?
Uh-huh.
What is 4?
No.
Emma, 2, negative 2.
No.
All right, Jimmy. Negative 1, 0.
1.
Josh, negative 1, positive 1.
Negative 1, positive 1?
Mm-hmm. Mm-hmm. Rebecca, negative 1, 2. What's going to be true about when we have an x coordinate in this example? These are all going to be 1.
It's going to be the same as 2.
And all of these slopes are going to be what?
Oh.
Okay.
So is that diagram a slope field then?
This is a slope field.
Good job, Aaron.
Yes. This is what, here, let me, oh, don't have it.
Magic pen.
So this represents all of our slopes, right? Basically, we have the general solution. If I gave you a coordinate, we could draw in a particular solution, okay? I want you to think about what our differential equation was. dy dx is x squared. And if we follow the, I kind of like to say, like, if you, like, it's going to take you where the wind blows, kind of thing. If we follow the wind, what do these look like?
We're going northeast.
Okay? They're steep, they get less steep to 0, and then they get steep, steep, steep again.
Oh.
What do these trend as?
Oh, it's the antiderivative, or the tangent.
It's
the
function.
one
X
third.
cubed.
It kind of looks like it would be some version of a cubic function, right?
Which is a,
And depending on where we start, they all differ by a constant. Okay, so this represents,
The antiderivative.
yes. So what is the antiderivative of x squared?
1/3 x third.
Plus C.
1/3 x cubed plus c. So these are all 1/3 x cubed, differing by a constant depending on where you start. Okay, so that's what this is representing. We can see that because we know what it's supposed to look like, right? Okay. Isn't it? Isn't it? Okay. I'm having such a terrible time. Okay. So here, y prime is x plus y. So now this relies on both x and y. Yes.
Oh, how can we just assume it's 1/3 x cubed? We're like, oh, it kind of forms the shape of x cubed.
Because if we actually did the differential equations, like if we actually solved this out, it would be 1/3 x cubed plus c.
Then why don't we just do that?
We take it. Okay? But, Brady,
or some of them.
look at this one. X plus y equals dy dx. We have no way of solving that differential equation. No way of solving it. So the only way we can even think about it is as a graphical representation, a slope field.
Okay, we just kind of like get like the curve of that.
Right. Right. So what we're going to do is we're going to plot our slope field, and then we're going to draw in a solution. So let's do this.
Yes.
So 0, 0, x plus y would be what, John?
You said 0, right?
0, 0, x plus y would be, if our coordinate is 0, 0. Yes. Okay. How about 1, 0? Nathan, what would our slope be?
1.
1, 1. Carter, what would our slope be?
2.
2. Okay, do you see where we're going with this? I want you to fill out the slope. So take a coordinate, plug it into x plus y, and that gives you your slope. My slope field is finished, so you can check yours with mine. Yes. So we'll follow that. Yeah, if you figure out a pattern, use it to your advantage. Okay, so since this is x plus y, you'll notice there's kind of a diagonal pattern, right? So 1, -1, 0, 0, 2, -2, -2, 2, -1, 1. Those are all going to have slopes of 0, so you kind of see that diagonal pattern. Okay? So this is something, y prime equals x plus y. We can't separate those variables and integrate both sides. It's just not possible. Okay? So we have our slope field here. This is representing the general solutions for our differential equation. Now I want a particular solution. Y of 0 equals 1. So that means we are going to involve the coordinate 0, 1. Then what I want you to do is let the wind take you. Okay? I know this sounds really lame. But so this is going to have a slope of 1. But then you're just going to kind of follow. Like I know somewhere in here it's going to have a slope of 0. And then change directions. That would be our particular solution. Let's keep going. All right. Match each slope field with the equation of the general solution it could represent. So basically, here are your slope fields. Here are the solutions. What does this look like? What graph? It looks like sine. So this matches F. What graph does this look like?
C or D?
A cube.
It looks like a cubic. So this would be D. Okay? Now, I'm going to make you think a little bit differently. Now when we go to the next set, now I want you to match the differential equation with the picture. Okay? So, this one here, dy dx equals x. Which one is that going to match up with? It's going to look like B. Because all of these slopes, so we find our slopes by x. So here when x is 0, our slopes are 0. When x is 1, our slopes are 1. Or like Zach said, this looks like x squared. This is the differential equation x. Okay. So side of x, this one right here, would match up with
D.
D. Because the antiderivative would be negative cosine. That's what that graph looks like. Okay. What about e to the x? Which one's that one's going to be? That one's going to be x. The antiderivative of e to the x is e to the x. Okay. Now, some of these aren't going to be quite as nice to think about. Let's talk about this one, x minus y. Anytime x and y are the same, we're going to have a slope of 0. So at 1, 1, we're going to have slopes of 0. At 2, 2, we're going to have slopes of 0, etc. So that's going to match up with E. Okay. What about x divided by y? And 2 minus y matches up with A. 2 minus y, anytime y is 0, we're going to have slopes of 0. Here, when y is 2, we have slopes of 0. Okay? So these you have to match up with. When you plug in coordinates, what slopes are you going to graph? All right, AP question. Are you ready? Not really. Okay, on the axis provided, sketch a slope field for the given differential equation. Go ahead and do that, please. xy divided by 2. Just to save time, all right, we're going to take a time out. We'll come back to that one so you can sketch in your slopes during announcements. But I want to talk about letter B real quick as much as we can. Letter B is asking us to write an equation for the tangent line to the curve through 1.1 and then estimate 1.2. So tangent line at 1.1. What do we need to write our tangent line? Derivative. What's the slope at 1, 1?
1/2.
The slope is 1/2. So our tangent line equation, y minus y equals slope times x minus x. Our slope was given to us by dy dx equals xy divided by 2. So then, without our calculator, we could easily approximate y when x is 1.2, or with our calculator. So what is 1.2 minus 1 times 1/2?
20, 10.
So our estimate is 1.1. Right? Okay. Then in part C, it's asking us to do the differential equations. Okay, so in part C, they actually want you to take dy dx equals xy over 2 and do the separation of variables. Okay, so we have dy, we have to divide over the 1 over y equals, I'm gonna write it as 1/2 x dx. Agree? Okay. So what do? We integrate both sides. Natural log of y equals 1/4 x squared plus c. Which means we have y equals c e to the 1/4 x squared. Right? Now, do we have an initial condition?
Yeah.
We have an initial condition of 1, 1. Well, we know something about our original curve, which means we can plug it in. So when x is 1, y is 1.
X becomes K and T at the same time.
Oh, no, I'm, okay.
Yep, you're stuck on Friday, right?
Yeah.
So our constant is e to the 1/4, correct? So our equation, y equals c times e to the 1/4 x squared, or we could write that as y equals e. We would add our exponents together, right? Since our bases are the same, we can just add our exponents together. Oh, gosh. Darn it. Thank you. C is really e to the negative 1/4, isn't it? Because we have to divide it over. Thank you for catching that.
Like, if we divide it over,
We have to divide e, so we have 1 over e to the 1/4, which is the same thing as e to the negative 1/4. So y equals c times e to the 1/4 x squared, which when we combine that, y equals e. I'm going to write it as 1/4 x squared minus 1/4. Okay? So that is our curve. We could actually solve that out. Now,
Hey folks, familiar with the South, I hope you all had a wonderful weekend. It is now time for the Pledge of Allegiance, so you may now rise from your seats. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. It is now time for your March 14th Titan Student Bulletin. Shout out, congratulations to the NJROTC cadets
with your
for earning
calculator,
first place amongst 13
I want you to
teams
plug in
at
1.2 for x.
Bellevue Regional Drill Meet. Grand Championship Award included a $10,000 scholarship to Bellevue University. Individual awards include dual armed exhibition. Second place to Eric Treven and Peter Vogel. Third place went to Alexis Paulson and Jordan Peterson, and solo armed exhibition. First place went to Eric Treven.
Oh,
Team
that's
awards
the
were
part of
first
C.
overall armed drill, second overall unarmed drill, first overall exhibition, first overall regulation, first armed exhibition, first armed regulation, second armed color guard, second unarmed regulation, second unarmed exhibition, first unarmed color guard, and first gear drill regulation. That is a lot of awards. Congrats to the NJROTC cadets once again. Information. Titans of Tomorrow will be at 7 p.m. on Tuesday.
Okay, we still need to talk about part B, so hang tight with me here.
Senior video. Seniors! We are starting to collect pictures for the senior video. If you have any group photos for seniors of senior students, send them to Mr. Bubba Pena at dpena at paplb.org. Please let me know the names of students, sports/club/activities they are involved in the photo. And group photos are the best. Please do not send individual senior photos unless it is part of an activity, club, or sports performance. Volleyball.
Okay, how did we know? So first of all, did we over or under approximate here?
Each individual must turn in
We
a
have an
form.
underestimate.
Hello, Titans. Student Council has put together a
Why?
Spirit Week.
Why did this underestimate?
For prom on April
Okay.
9th,
If we go back and look at our
we will
picture,
start off the week with Lazy Day. Pretty much every day. Monday, April 4th.
at
And
1-1,
Tuesday, April 5th.
what's
you
going to
will
be
have
true
a
about the
big day
concavity
to
of our
grab a
curve?
friend or your twin.
Concave up, which means our tangent line is
Wednesday,
sitting
April 6th, will be
underneath.
Spirit Day.
That is
So
why
that's
we had an
all your
underestimate.
ideas. Thursday, April 7th, will be your prom theme. That will be announced at a later date.
Because we can look
And
at this right
finally,
here.
April 8th will be the Flannel Friday. This is an entire school event, so even if you cannot go to prom, or you just are not attending, you can still dress up and show your school spirit. Go
We
Tigers!
have Spirit Day for prom?
Well, that's
Damn it.
Jimmy, you ever ever had a
Yeah.
Are you serious?
Yeah.